Welcome to More Than a Refresh, a podcast about data and the people who wrangle it. Our guest today is CTO and co-founder of Yugabyte, Karthik. Now, Karthik, you're going to have to help me a little bit here. How do you say your last name?
Ranganathan.
Ranganathan. Okay. And
That's right.
Can you introduce yourself a little bit to our audience?
Sure. Thank you for having me here, JD, first off. And hey, everybody, I'm Karthik, as JD said, one of the co-founders and the CTO of Yugabyte. I've been in engineering and R&D like my entire career, like about 20 years now. Before starting Yugabyte, which was early 2016, I was working on distributed data at Nutanix, and before which I was at Facebook for 6 years. I was fortunate enough to be a part of the team that built an open sourced Apache Cassandra out of Facebook, and subsequently worked on HBase. So I'm a committer in HBase as well. We were also the team that ran it in production, and of course before that I was at Microsoft and a bunch of other things, right? But yeah, that's primarily it in a nutshell.
And we know each other from the Postgres conference series, right?
That's right.
Okay, so we have our standard questions here, but I do have a couple of speaker-focused questions. Like, what is your typical day like as a CTO? We know that you're funded. You've done at least one series. How many series has Yugabyte done so far?
We've raised about 3 rounds. Yeah, three rounds that we've publicly discussed. We're in Series B. We're running on the Series B, but okay. Yeah, we've raised a few times. Yeah.
And so, as a founder, you were there since the beginning, right? When it was just an idea of, hey, could we pull this off? How has your day changed from, say, 2016 now with 2020 and even the added stresses of, say, the pandemic? What does your typical day look like?
Yeah, that's a great question. I think maybe I'll start from the beginning, right? Like back when we were starting, it was an interesting time, even leading up to the start of the company. We were just trying to figure out, like, having worked in databases and distributed systems for so long, and having built multiple databases, right? Myself and my co-founders together, we were thinking about where the future of databases what would it look like, right? And where would application development go, and what did we want to do, right? We were quite clear we wanted to focus on the OLTP, online transaction processing side of things, not the analytics or OLAP databases. So we started looking at it from that perspective, and we realized that the world had not yet headed into the cloud. This is back in 2016. And when we looked at what it meant to be cloud native, right, there's a lot of research that goes, and we looked back at our experience from Facebook, talked to a number of people. So back then, the thing was more definition oriented, trying to make sense of what is a hazy area and is this of interest and so on, right? And we saw that there was definitely a demand and interest, and we saw, like, our prediction was that apps would go into the cloud. Again, was not always the case back in 2016. Many people would tell us that they don't really have cloud in their strategy, and they didn't want to put their applications in the cloud back then. But based on what we had seen of cloud native apps at Facebook, we felt like this is the direction things would go. So then there was a long build phase. Like, databases are notoriously hard to build, so a lot of build phase. But it wasn't just building; it was working, talking to users, and people interested in using such systems, such databases in parallel. So trying to define what we're building with what the ask is, and trying to align those two closer and closer, right? So this went on for about a couple of years, and after which we got into the other uncertainty in 2016 was everybody was sure that database as a service was the future. However, everybody except the customers who would use it, right? None of the people we spoke to would be like, oh, I'm not using the cloud, and I'm sure as hell not putting it into somebody else's hands, my data, right? That seemed to be echoing loud and clear. So a piece of the strategy was, and open source companies, would they make it? Would they not? It was unclear. Should we go completely managed, like, for example, a Snowflake? It just wasn't clear back then, right? So we said we'd do the one thing that matters, which is build the product and talk to people and make it useful. And we would decide if we're running this as a completely managed service or open source it later, right? So after a year and a half or so, the later had arrived. And so it was time to figure that out. And at that time, we really did our research and felt that being open and being completely permissive in terms of license is the way we wanted to launch the company. So till then, we'd just been in stealth building the database. And Postgres, right? We met in the context of Postgres, JD, and Postgres had a lot to do with it. We saw that Postgres was just becoming popular like crazy, and a lot of it had to do with the openness. So it's important to stand the test of time as a database, right? That's the most important thing you can do, especially with a mission critical database. So we said we're following that path, launched the company, and then there was a lot of stuff around getting the word out about the database, getting users to use it, understanding their feedback, helping them out to get successful, like evangelizing the database, also collecting feedback to make the next set of features. So there was a lot of stuff around it. And there was also like the hard design problems around how do you do something when you're up against the edge of distributed systems, and what transactional databases offer and what you would do in the cloud. And so there was a lot of that also, which, I mean, it was a lot of fun actually. And fast forward to today, like I would say, like with the pandemic, actually, we saw a huge uptick in the number of people starting to adopt the database. Communities completely growing like crazy. Number of enterprise customers have gone up quite a bit. I think there was the complete, like we went from open core, which was the model that was the prevailing wisdom back when we launched the company, to a fully open source, exactly like Postgres. Like we go completely open source and embrace the community completely. And that gave us our first big impetus in terms of momentum. The next big one in COVID was actually very like transformational in the way people started moving online, and that helped a lot. Fast forward to today, I'd say we're in a rapid growth phase today. Like it's gone from defining the product and the space to actual code and building features, to evangelizing and working with people, to now it's just like figuring out whatever it takes to just make it through the week, because of the rate at which things are scaling. So it's a good place. It's a good problem to have, but there's still the process and the way you scale while still keeping the quality and the feature set, and still not lose the agile edge to the company, and still being friendly to developers and open source. There's a lot of sides to balance. So that's roughly, I'd say, probably a long answer, but yeah.
That's quite all right. You actually brought up a couple of really good points that I'd kind of like to expound upon. Back in 08 or 09, we ran a conference for the community at the Hotel Penn in Manhattan, right across from Madison Square Garden. And this was when the marketing people had finally realized that virtual machines and virtual hosting and everything would be easier to sell if they called it cloud. Uh-huh. And so we had a panel in front of the conference, and the conference at the time was small. It was very intimate. It was more like the Silicon Valley conferences, where we're talking about 225 people versus our big Manhattan conference. And the most interesting thing to me was during that panel, we had a series of experts who had been dealing with this for years. A gentleman got up and raised his hand, and he was frustrated. And he gets the microphone. He looks and he goes, "Could someone just tell me what the hell the cloud is?" Right? And we couldn't help but laugh a bit, because I mean, really, it's just it's a reimagining or a rebranding of things that we've all been doing for many years. Even database as a service isn't actually all that new. But in your particular situation, I have to bring up. I heard from the open source grapevine that Yugabyte was originally going to be Cassandra based. Is there some truth to that? Because now you're primarily all in on Postgres, right?
No, I think it's both true, actually. It's actually an interesting story. The first, we actually, we got, we went to meet with Ravi Mathur, the Lightspeed, the VC out of Lightspeed, is tremendously successful. We knew him out of Nutanix. It was just a general casual conversation to catch up on what we were up to next. And the idea was, hey, we have this idea of what we are thinking about databases, and it was just having a conversation, and it just sparked so much interest that before we know it, we got funded and we had started a company, right? But the first pitch deck, right, the hypothesis was that we had to be necessarily multi-API as a database, right? And the logic is as follows. When we told people, hey, we're building a new database as a database company, the first reaction that everybody had, 10 out of 10 people, was, why the hell are you doing this? There's 300 databases. Why are you building the 301st database, right? And the reason is not so much that we were building a new database. They were worried that we'd come up with a new language that they'd have to learn and a new language that has to like integrate with so many different ecosystems. And they like probably build, and they were worried like based on NoSQL and so many things that happened that 2 years in, like I'd now have a few applications running in production, so I can't get rid of this database. But then I find out I can't do 20 things with it, and now I have to add a new one, yet another database on top, right? So that's the part that we consistently heard. So the hypothesis for us, the way we wanted to build the database was to do the inverse. We wanted to actually support multiple APIs on top with a common data storage layer below, right? So what that means is you can actually consolidate some of your database workloads on top of a single database as opposed to having a proliferation of databases, right? So the original, like if you think about database classes, right, what people do with databases, there's SQL and there's NoSQL, right? So we had to pick one in each category. Now, the strength of NoSQL was its scalability, multi-region deployment, geographic distribution, built-in replication, and performance, right? Depending on how you looked at it, it's actually good performance for the scalability you get, right? The SQL side obviously had a lot of strength with respect to transactional, and Postgres is just off the charts in this, right? Like the transactional integrity, just the sheer number of query features that you get, and all your other things that come that make the database extremely extensible and extremely powerful for applications. So we knew these were the two sides, right? Now, in building a database, we wanted to go from bottom up. So we had to lay the foundation, right? And so we said, let's pick, and we had to compromise on one side or the other. We couldn't be building all the feature depth and all the distributed available depth, right? We couldn't be doing both at the same time, right? Because we had to start somewhere. So we said, we'll pick something that's a simpler API on top and kind of focus on the availability and the basic transactional characteristics. And then we would go for the complexity of SQL, right? Like we'd go for it all out. And by the way, when we started, we hadn't zeroed in on either the APIs we'd put and not on Postgres, none of that, right? We just the mission was SQL and NoSQL literally in the platform, so that if somebody wants to build an app and they want a NoSQL flavor, they can. If they want to do a SQL flavor, they can, because your microservices have a spectrum, right? Like you have things where like total data set size is extremely important. You don't have too many complex relations. And you have things where your data set size may not be so much, but you really, really care about your relationships and your relational integrity and schema and all of that stuff, right? So as we went forward and we picked the Cassandra API and Postgres specifically because Cassandra also had tables. However, it's a NoSQL database, and Postgres was just like the most open source and awesome database that we found on the RDBMS site. So it's true that the intention was never to only stick to Cassandra and switch to Postgres. The intention was always to build both. The question was sequencing, right? Which one would allow us to build the database in a way where we could, like, you don't want to keep building the database for 5 years before it comes out, right? So we had to build it in such a way that we could bring something meaningful for users to use while we focus on the next leg of the journey.
Okay, that makes sense. So is the Cassandra API, is that still a tier 1 supported version of Yugabyte, or have you gone all in with just Postgres compatibility?
No, it's a tier 1 supported API, and while like we saw that the community mostly is gravitating towards Postgres, and it's because it's such a rich and strong offering, there's still a good chunk of people using the Cassandra API specifically for some features that are more NoSQL-esque, right, compared to what you get with an RDBMS because of the natural evolution of these systems, right? Like as examples, you have in the Cassandra API, you have the ability to not require a load balancer. You can take your application and connect it to a single node, and it'll discover all nodes of the database, right? Like all nodes in the cluster, and it can now start doing one-hop routing and reaching data and doing queries against all the nodes of the cluster. And then you can add a few more nodes, and this client, this app that's running would automatically discover those new nodes. You can remove nodes, you can have nodes die. So it would basically subsume a lot of the work that the load balancer does in a smart client. And it also does topology awareness, where you can say, hey, read from my nearest data center, right? So if you just think about this for a second, right, you don't get relational constraints, but you get all of these features. It's closer to a transactional serving tier, right? Like where you want low latency, one-hop routing, simplified relationships, but ability to handle a lot of data. So that's the piece of the offering that we matured, because it's got to be high performance. It's got to be like capable of holding a lot of data, and it's got to have strong characteristics when it came to failover and scalability, right? So we did focus and mature those. And then the next leg was to go for really what people were looking for quite a bit, which was, which is Postgres. People just loved it. So in fact, the first version of us trying to incorporate Postgres was to say, hey, why don't we just write it from scratch? Because it's maybe much easier to build those features one after the other. And we actually we worked on it. One person did this for about 5 months before we realized this is just a fool's errand. They were never going to get this done in time because Postgres' query layer and feature set is just off the charts, and it's just not possible to replicate. It represents 30 years of solid engineering. So we said, you know what, let's go the other way. Let's actually take the Postgres upper half and see what we can do to engineer this thing. It obviously was, if you think about it, it was an unknown, right? It was risky. Like, as in, is it possible to take such a complex code base and get it to work on top? But obviously, we had a strong team, and we were really determined to do it. And the Postgres community and folks such as yourself, super helpful. So now we're at a state where we actually got that, and obviously, a lot of gravity towards the Postgres side. So people still come in and self-select, but obviously, there's a huge portion of the community and users that go towards the PostgreSQL side.
Well, I find that to be true too. As you know, some of the terminology or statements that we've been saying is, Postgres is the world's database, or the Linux of databases, because Postgres is so universally accepted now.
Yep. Very
one
true.
of the things one of the things that I run into is, you still have your stalwarts, right? Your Oracle lovers, or your Microsoft SQL lovers, or your MySQL lovers. And we don't even try to countersell them anymore, because the market is kind of spoken between the clouds, all major cloud vendors, as well as, startups like yourself, and even, larger companies, like VMware and Greenplum, for example. They're all moving to code parity on some level with just Postgres, because it greatly reduces your need to maintain a good portion of code. It's not just with Postgres, and like you said, the executor layer, or the SQL, or the transactional robustness. It's also drivers, right? Yep. If you speak the wire protocol, you don't necessarily need to write your own Python driver.
Yep.
And that kind of rolls into something. You said that the Cassandra is very strong, which is great. We've encountered Cassandra in the past. It does seem like a very useful database. Not going to lie, we're a Postgres shop. I'm curious. I mean, you alluded to Postgres kind of being the direction that the clients were choosing, or users was choosing. Are you finding that, and you kind of already said this, but are you finding that your choice of Postgres has actually helped your company move forward and helped your technology move forward at a rate beyond just, obviously you said that you tried to engineer it yourself, and I mean, you should have just called me. I would have told you that was a bad idea. No, it's funny. And the reason I say that is because I actually remember when you said that. I remember the talk the first time you spoke at Silicon Valley. You gave a presentation basically on the origins and how you developed it. And then you realized that was a bad idea, and so you went to a different direction. And it just reminded me of that. Seriously,
that talk was the first time we got Postgres to run on top of the distributed substrate. So we were all super happy back then. I mean, it must have showed in the talk, but anyways, yeah. Side note. Okay. Anyways, go ahead.
No, you were obviously excited. Yeah, it was a great talk. I remember sitting in there with some of my peers, and they were impressed. And these aren't people that are necessarily easily impressed.
Awesome. Good to hear. Good to know.
Do you find that, that your choice of Postgres, certainly other vendors have found great success. Do you think that it has partially been a key to your growth and the success that you're encountering now?
Yeah, I think there's really no even question about that. I think that's absolutely true. So I would say that decision of switching to reuse Postgres was quite pivotal for us at Yugabyte. It's just because of many things, right? Like when we thought about the original strategy of rewriting, we wanted to rewrite it to spec, right? And we knew that, yeah, we could get all the queries and the basic stuff right. That's not too hard to do, right? The ANSI SQL part, so to speak. But then PostgreSQL has so much more to offer on top of the ANSI SQL stuff that it no longer is even a fair comparison to think. Like for example, what are some of the things that we've been able to accomplish that I think nobody else is able to accomplish as a distributed database, a truly horizontally scalable database, right? We just support all of the or most of the partial functions, stored procedures, built-in functions, triggers, user-defined functions. Heck, we even support a ton of extensions now. We're thinking of supporting foreign tables. I don't think these would have been easy, even close to easy to do, because if you think about each of these features, right? When a database thinks about implementing, say, stored procedures, right, they usually think about speccing it and then implementing it one line at a time and one language at a time and then one feature at a time. And this is a very long road to build, right? By the reuse of Postgres, we were able to actually do everything Postgres does, which is not just impressive in terms of its sheer depth today, but also in terms of how well it has been designed and thought out, right? Because not only do you need to build this, you need to mature this in the context of a real-world user or application, right? At least not even many real-world users and applications, and the feedback cycle and bug fixes and so on, right? The second piece is around testing. We are working on moving Postgres' regression suite, as in we keep enabling whatever set of features we support in Postgres, we enable those regression tests also. So it's not just high quality code, highly designed, well documented, well spec'd, right? And with real world use. It's also the testing and robustness around the code and all of that. So it's just been an incredible amount of a great engineering and a great product that we just got for free. And it's and Yugabyte is free in turn, so it's not like we're just taking it and not giving back. So just happy in that sense that we're able to give back to the community as well. But the way I think about it is, even though we have other APIs and that's real value to people, I still consider Yugabyte as a part of the Postgres overall ecosystem, where we're able to offer something that is pretty closely Postgres in spirit, right? Not just the wire protocol. It's a lot more than that. People are interacting with the upper half of Postgres, like the postmaster and the query planner, executor, rewriter, optimizer. A lot of that is the same, of course, with modifications going in to make it truly distributed, right? So I'd say yes, it's a resounding yes. It's helped a lot.
Well, that's good to hear. You brought up some interesting points. There's always a challenge for what are essentially forks, right? If you take a look at, say, Aurora, they are quite a bit behind in terms of code parity to the PostgreSQL.org Postgres. What code parity reach are you? Do you have a schedule that you adhere to, or do you try to stay with lockstep, or what version are you currently parity?
Yeah, so we started out with 10.4. We then rebased to 11.2. We then added a bunch of features, which is 11.2 plus. Which are some of Postgres 12 features, but I wouldn't say we're at parity with Postgres 12. We have an initiative that we're staffing where we want to get to feature parity with Postgres 12. So that's I would imagine that in the steady state, we are going to continuously play a little bit of catch up, and there's going to be, we're going to have parity as of some version, which keeps moving forward over time. But we are going to, selectively pull in features where where we see a lot of demand from, future versions of Postgres. Specifically in the case of Yugabyte, as you know, it's a truly horizontally scalable database, including the system catalog and everything, right? So that means there are portions, and also in a truly distributed database, you do have to change the way a Postgres executor or the Postgres optimizer works, right? You just have to do things a little differently to make it more optimal. So for the distributed execution. So in that sense, I think there are areas where we might have to figure out how to merge the code, or even perhaps re-implement small sections because of the differences. I think those are par for the course for us, because at the end, I think the value of all that work is still incredible for the end user if they want a horizontally scalable and a highly available internally replicated PostgreSQL, right? So it's still highly valuable for folks. But yeah, that is par for the course. And in spirit, we'd like to stay as close as possible, over time, even try to think about how we can modularize some of those changes we've made by making contributions upstream. But I think we're at a stage where we're still playing catch up on some of the other features. So I don't think we're quite at a spot where we can, fork off and invest in that, but that time will come. So, yeah. if you remember, we chatted about this, right? Like, how can we use make changes upstream to leverage it downstream and so on. So ideally, we'd like to do that. But yeah, it is. I think we're still a small company, so it's in the grand scheme of things, and the time will come for that.
There's definitely a challenge there, and I think that there's a challenge for any ecosystem member that wants to contribute back to the community. And this would be the case of any project, right? It's not just PostgreSQL, but every community has their own process, has their own level of various things that you have to do to get a patch accepted. And then when you do take something where, PostgreSQL is an official project, has been around for, 23 years or something like that. And there's a lot of long-standing, this works for us, we don't want to bend. And, that's not a detriment to Postgres. It's just the way the nature of, especially as projects get older and more mature, that just kind of happens. But it is definitely good to hear that you have a goal of contributing at least some of the work back, because it's good for the community.
Absolutely. And I don't even view this as maturity and all of that aside, right? Like, I think the design goals may be slightly different in the sense Postgres is trying to be an exceptional single node database, an RDBMS, and Yugabyte is trying to be an exceptional distributed RDBMS, right? Distributed PostgreSQL. And so the design will change between the two. It's just bound to. Otherwise, if it doesn't, it's almost like saying a single node database is ideal for a distributed database. A single node database design and implementation is ideal for a distributed one, and that's not true. So there are some changes, but I think that's the part where we have to tease apart what are the pluggable portions and what are the common portions that can go straight up. And I think that's the work that we have to invest in. And once again, like I said, once we get to a higher degree of feature parity, although we support a lot of features, there's still a bunch we don't, right? So those are the things we're focused on. So once we kind of get it to that point, I think those are things we'll start considering and working on.
All right, great. Well, I'm going to bring up something now that you alluded to as well. But as you know, in the open source community, actually in the market as a whole, there's been some pretty high profile companies that have moved away from open source.
You mean anything that would start with an E and, and with a C?
Yeah, well, that's one of them. Yeah, that's one of them. But there's even one of the Postgres companies that has moved kind of away from open source, and we certainly don't need to name names, but I think one of the interesting points has been in open source as long as I have. I've been doing this since before I even understood what open source was. My first time I installed Linux was in 91. And one of the things that I find interesting as, our communities change is that there's this sense of almost entitlement where, because a company makes something open source, they have some kind of intrinsic right to it, which is actually antithetical to what open source actually is, right? So when someone, right? So when someone open sources a source code and makes it either an open source product or an open source project, which are very different.
Yep.
And then someone else comes along and forks that and then monetizes that. There's somehow a feeling of betrayal. And I'm kind of curious, especially with some of these more high-profile companies that have taken this approach because they clearly didn't understand what open source meant. Open source is not a business plan, right? It's not a business strategy. It's an ideology that you can build around. So what are your thoughts there? I mean, you guys have taken the high road of being open, being giving. Do you have fears that one of maybe the cloud providers will fork Yugabyte and turn it into something that you can't compete with?
The short answer is yes. I think the fear that somebody does that always exists. But we had to think through this, fortunately, because we saw that this was coming even as we started the company, and. You can kind of think of Yugabyte's journey as almost a blank slate to thinking about if you were to build a company, which we did in 2016, there was tension between Amazon and Elastic. There was tension even back then. There was tension between Amazon and Kafka, Confluent, and all of these other products that they were running, right? So this was something we had to contend with almost in the DNA of the company. Here's my thought, right? I think that open source, a lot of companies view it as a marketing mechanism and then switch it over when they think they don't need that channel of marketing. They don't, unfortunately, think about the betrayal of the community itself, right? Because the community got formed on some basis, and now the basis gets shifted, right? So, yes, there's going to be some short-term monetary benefit to stopping other people from coming in, but the saying I've always liked is be greedy, but be long-term greedy. Don't be short-term greedy, right? So it's actually a better way to build a business than to just go after what you can do in the short term. But to answer your question about what our thought was, we think that a lot of these companies are facing such stiff competition from the cloud because they were a little late to the cloud game. And in any company, any project, any company, you have to keep placing your bets on what are the secular trends and technologies that you want to integrate with. And the simple truth is everybody ignored the cloud, and it grew up way quicker than they could imagine. And so they all got caught in this compromising situation where on one side the cloud became really big and no one was ready for it, and on the other side the cloud providers took what was open source and quickly monetized. I mean, by cloud providers I'm talking about Amazon primarily, because they were the ones whose cloud grew the fastest, the earliest, right? So the first mover. So they were just able to do that, and like Amazon, for example, didn't do that from the ideology of ripping off somebody else's work. They were simply trying to make their cloud more valuable, right? Like, I mean, what is the use of a cloud if you cannot have services? And that kind of paved the way for the others to realize, oh, there's a huge revenue stream here that I'm kind of missing or whatever, right? Now, imagine it went another way. Imagine that nobody paid for a cloud database and nothing really happened. Amazon would still have done it because it would have helped somebody. But all of this, change of licenses, nothing would have happened, right? The core question to ask is, if you are a company that, if, let's say, as a cloud vendor like Yugabyte, we already are working and investing in our own fully managed cloud, and we have strategy. We have a product that is a software-defined version of the cloud that is self-managed, that can run in any cloud, right? So if you now think about our value proposition, I'm now talking business value, right? I'm not talking about the open source portion of it, of course, but the reason why people end up paying a cloud is for the ease of operations, right? It's kind of what Red Hat did to Linux, right? It's the ease of consuming that product, the database. Now, if each of the database vendors had themselves offered a cloud, the question is, would everybody go to the database vendor or to the cloud? Because all of the ease of use is there. I mean, assuming that the cost is within margin, you'd want to go to the database builder because they can often build you better features, quicker, release faster. You have the latest access to the latest features, quicker to turn around bugs and all of that, as compared to a cloud vendor that has to, arm and do this and kind of lag the database company in some sense, right? So in that sense, the value proposition that Yugabyte specifically offers is the ability to run like Yugabyte DB and completely managed in any cloud, or to manage it yourself and even deploy it yourself in any cloud or across clouds like private, public, whatever it is that you want to do, multi-cloud, all of these are fine, right? So at that point, it becomes more than just a fair fight. Like, the odds are slightly more tilted in our favor, we feel, and that's because we are kind of doing this work early on as opposed to having to do it later on. But to the point where departure from open source and the ideology, I think the reason why open source is interesting in the first place is not just, it is my opinion, is not because it's just a marketing vehicle. It's because it keeps the builder of the database on their toes and forces them to provide value, democratized value, right? So people know what they're paying for. One of the biggest complaints about Oracle, for example, is that, and I hear this a lot, is that it's very expensive, right? I think the reality is people don't know why it's expensive, and that's really what gives the notion of it being expensive. If they knew exactly what the feature was, how it works, how much it would take for them to run it themselves versus somebody else to do it, then they can make the bet on whether they want to invest in just people who can be a part of the community but operationalize it for them, or just consume it from the vendor that operationalize it off the project, right? So it's just, at the end, just business. It's just a business case, right? So.
Well, it's interesting that you bring up Oracle, because let's be honest, Oracle is expensive. The reality is, if we're talking about open source, right? If you take Postgres or you take Yugabyte, since you kept it completely open, anything that costs more than zero is expensive. The question is, where is the value that you're, like you said, right? If you're bringing value to the table, that expense can be worth it. But I even have a presentation. I gave it I gave it at a conference in 2017, and I've done it a few times. But with the line items is that, basically Postgres has been innovating a way for you to work with your data for over 20 years. Oracle created an entirely new market for attorneys. Like you type in license compliance, right? Yep. It's ads for attorneys to against the audits from Oracle. And we all have our business, the way we do business. I'd like to think that, and I happen to know that Yugabyte is one of the more friendly companies to work with. And that actually leads me to something a little bit off to the side, because we could go, I'm sure you and I could, chew the fat on this open source thing and businesses and culture and community all day long, because it's an ever evolving thing. Especially when you start talking about, when they're talking about what is it, open core and the SSPL, and the reality is what you have now is a good portion of the market and is starting to recognize that open source actually exists. And what I mean by that is that when I talk to people every day, the people that we normally talk to in our circles, of course they know what open source is. It's where we're from. But if you look at it from a holistic perspective, if we look at it from a universe, right? If you talk about our solar system, open source is only Pluto. We still have to deal with Mars and Jupiter and Earth and Mercury and Uranus and all this stuff. And in terms of, global penetration, it is certainly true that everybody on the planet who has a computer is running something open source at some level, but they're not necessarily aware of that. And that's where the shift is coming from, like you said, with, it's a marketing thing, right? It's all of a sudden people are tapping onto that. And when you have these companies adopting, for example, the SSPL or something similar, they don't want to let go of the moniker of open source, because that's the direction it's going. If you're not dealing with a very specific trade secret, why is your code not open? I think that there's kind of a reckoning that's going to come around in the next, 6 months to a year, where the people in the know are going to start pushing back and saying, no, there's nothing wrong with the fact that you're SSPL. It's your code. Do with it what you want. But basically, by calling it open source, you're lying to the community. And I think that is, and it's not just community. You're lying to customers.
Because that competition that it fosters and forces the vendors to be on their toes and make it better and offer more value, it really comes from the truly open nature. It's not just like having your code, but proprietary out in the open, right? It's truly letting people take whatever they want and do whatever they want, because you with that, you have to build your confidence that whatever they do, you can do it better and offer more value. And that's the true spirit of competition. So, no,
and you can apply that to automotives too, right? Is that, when you look at, say, a Toyota Corolla, perfectly fine car, a reasonable car, high quality in terms of reliability and that type of thing. But it's not a Lexus, even though it's the same company, right? So there is definitely a direction where if you're doing the good job, if you're doing the best job, you may not get all the business, but you're going to get the business that matters to you.
Exactly.
All right, so let's switch off of this a little bit, because you and I you don't have the same. I don't think you have the same logo anymore. At one point, you had a logo that you had a giggle about. And I'm not. We don't need to actually. We know what we're talking about. But where did the name Yugabyte, right? Huge Yugabyte. What is? What are the foundations? The scientific foundations of this name?
Well, Yuga in Sanskrit means an epoch or an eon, right? It represents a very long period of time, right? So Yugabyte is a play on the fact that, like, you have, gigabyte, terabyte, petabyte, like those represent the size of data. But what also matters is how long your data can live for. So Yugabyte represents the fact that your data, irrespective of the size, can live for a very long period of time, right? So that's really the genesis of the name. And it talks about the way that the database actually can replicate data, survive failures. Actually, you can move the database or the data while serving it from one set of machines to another, from one cloud to another. So you can do all of these moves, which become very important if you take a long-term point of view, right? So these are some of the critical operations that become hard if you don't build it right into the architecture from day one. So yeah, that's really the origin of the name.
Well, that's great, because now, I mean, you said something eons, right? Or how an epic, how long can your data last? Well, I think that we are finally coming to a reality point in today's world about how long data actually can last, because we're starting to see a lot of stories of, I mean, I don't know about you, but when I was younger, there's certain things that I would never do again. And I certainly don't want data points in some database somewhere. Select star from when JD was dumb. I don't think that's a long table that we don't need to
yes,
bring to
totally
the forefront.
Totally agree. Glad to be past that phase in this age of data longevity. So, anyways.
All right. So, from a business perspective, you do have a slightly, kind of a marketing slogan. I assume Jimmy or someone came along with it, but no hidden traps to slow you down, fully open source, even for enterprise features, which I think is fantastic. Although I do think that there is a certain value add that an enterprise class can bring to the table that you may not get in the open source version. I also have to admire if you've come up with a business way of being able to sell a truly free product and have different versions, right? So what is there a difference between, what I download and the enterprise version, or is the enterprise version more like you get support and
no, you get actual software in the enterprise version, but the way to rationalize the difference is as follows, right? Postgres as a database is fully open source. And let's say RDS or Aurora, right, as a database is essentially Postgres, but I guess Aurora has some specific code, but let's take RDS, right? Like RDS is actually an operationalized version of Postgres, right? Like where you get machines provisioned for you, right? You get the software installed, you get the upgrades done, you get your backups taken for you, you get your turnkey encryption. So all of that, right, is software that the Yugabyte platform has. The database, though, is fully open all the ways, right? So just like Postgres. So everything enterprise, like you could do all of this yourself, but the enterprise version makes all of these other tasks we just talked about, all the way from spinning up machines in your AWS account in a specific VPC without giving it public IPs, and installing the software, networking them together, allowing the security groups you want, like, doing nightly backups, integrating with your KMS stores for encryption at rest on the wires, and so on and so forth, right? So metrics, monitoring, rolling upgrades without downtime, all of this stuff is encoded into software and is something that we sell as the enterprise version. So it's got nothing to do with the database. It's got everything to do with running the database in a production grade environment through software, right? So that's the part that is our first commercial product. Of course, the second one is a cloud where we take that for you, and we take care of the machines and everything, and just give an endpoint that people can connect to and run, right? So these are the two versions on the business side. The database itself, of course, is fully open.
Interesting. So, being in the data world, you brought up something that's very important, encryption. And your exact words were turnkey encryption. Now, someone who's been doing this for a long time, that declarative of a statement has to be expanded on. In Yugabyte's mind, what is turnkey?
Yeah, I think so. Okay, so let's say you think about encryption, right? Like encryption automatically splits into two pieces. There's encryption on the wire and there's encryption at rest, right? Encryption on the wire further splits into two pieces for a database like Yugabyte, which is encrypt the data between the applications and the database service, and encrypt the data between the database servers, which themselves could be across different regions, etc. Right? So there's a lot of pieces in this puzzle already. You have to go through how to enable each one of these pieces. Then you have to go through how to set up the credentials for each of these pieces. What credential does it need? Where do you need to put what? How do you get the whole thing to work? How do you ensure availability? All of that. Then you need to integrate this whole thing with the source of these credentials, like so a key management service or your certificate stores or whatever that is, right? So you need to get the credentials from somewhere in the right format, put it in the right location, and get the database to recognize it and now distribute it, across the different nodes and whatever, right? So then there's the next piece of having to rotate your credentials, right? So you don't want to keep the same password forever. Similarly, you don't want to keep the encryption keys and and your certificates the same, right? So you want to rotate them. You want to change them over time to make sure that even if somebody did get access to some piece of these credentials, to these keys that can be used to decrypt the data, it wouldn't last forever because your keys keep changing over time. So who does the rotation? How do you make sure that you've rotated it in your key store, but it also reflects its way into the database and do so in a highly available manner? All of these things, right, are operationally complex. There's things that have to get figured out. And, you can take Yugabyte, you can do all of this stuff yourself. It's completely possible to do, and we have good documentation for it. But, the issue about running this in a mission critical application, or when you have a lot of applications that you're building and your scale is large, like you don't want to make a mistake, right? So you don't want to make a mistake either by doing it manually. You don't want to make a mistake even if you encoded it into DevOps because there was a bug in your DevOps code, right? So people come to us to make sure they do that in a way where they can trust and run it and so on, right? So that's I was just encapsulating all this into that phrase, turnkey encryption, but yeah.
Okay, so just to elaborate a little bit, you're using encryption over the wire. But it sounds like you also are basically doing transparent data encryption through rotating keys.
Yeah.
Fantastic. That's fantastic. So let's talk about the architecture a bit. We've got a few minutes left. The thing that I found interesting most about Yugabyte is solving the multi-master problem, which is not exactly what Yugabyte does, as I understand it. You're more horizontal scale.
Yes, we do both. Yes. So one of the underpinnings that we realized was that people need all kinds of replication in the cloud. Like, it's just a Lego block of features that you have to kind of compose and build depending on the exact microservice that you need. And the two fundamental forms of replication are synchronous and asynchronous replication, right? So Yugabyte supports both, because replication is so core to the database architecture. In the case of Yugabyte DB, you can have like 3 nodes sitting across different, far away or nearby regions or zones, and you can have them synchronously replicate data. And you can have this system asynchronously replicate data to a completely different cluster sitting maybe in a different portion of the world, right? This deployment topology is sometimes super useful in scenarios where you can compromise the data replication consistency. Like, you don't want to wait for the data to get replicated to a faraway region. However, you need low read and write latency, and you can deal with the asynchronous lag of replicating data, right? That's an important pattern, as important as having it synchronously replicated across faraway regions. So we are truly able to support multi-master as one deployment paradigm, where we have 2 clusters that can bidirectionally asynchronously replicate to each other. We can also support 3 regions that are far away that can synchronously replicate to each other, but obviously the characteristics of latency and throughput on the application will be dramatically different between these 2 scenarios, right? In one scenario where you're sync replicating, you could have high latencies if your regions are far away. And some applications need that. Like, for example, a config map. You want to read configuration. It doesn't change often. You want to read it all the time from your nearest region. However, when you write it, you're okay taking the hit, right? Versus think about a shopping cart. Like, you want the shopping cart to be highly redundant and available across regions, but no one wants to wait for the right latency to a remote region in order for it to be completely consistent, right? So there's different things. Yeah,
I think that's interesting. One of the things that we run into quite often is, someone will come and say, "I need synchronous multi-master." And our response is, okay, so what is the problem we're trying to solve? And inevitably, it's because someone thinks that it's going to increase their performance. And one of the things I'm always saying is like, synchronous multi-master has nothing to do with performance. That's not the problem you're solving.
Exactly.
It's an interesting world because database is a specialty. And, something that we've observed in the market recently, or really over the past few years, is that people are starting to recognize that again. It used to be, when we were young men, you had your systems engineers and you had your database engineers and you had your programmers and your operating systems guys. And then, in the early 2000s up through even, say, 2012, 2013, everyone tried to mold that all together. And I think part of that is because you had a lot of people who were not technical. They don't understand there literally is a difference between your systems administrator, who is just as important as your
Yep.
database engineer, but they're totally different disciplines. And so what happens is you get your common developer who are very talented, but they know their paradigm and only their paradigm. And then you get them saying, oh yeah, we can do multi-master. That is not a simple problem with the database. There's a reason why nobody does it particularly well, right? And so it's interesting to me. I mean, outside of the obvious, right? We have the obvious of latency. We have the obvious of referential integrity, conflict management. Were there any gotchas that made you actually kind of sit back and look at the whiteboard and go, huh, we didn't think of that one?
I think as are you asking as users use the database or as builders of the database when we realized something?
Builders of the database as a user problem.
Yeah, I think, no, there were actually a lot of interesting surprises. I'll tell you a funny one in the case of Yugabyte, at least, right? Like, so we were using Postgres on top. We are using Postgres on top, and it looks up like, stuff from the system catalog. Suppose you have a user-defined function, right? The Postgres would go through its types on any Postgres SQL database installation, right? Would go through its own primitive types, and if it's not there, it's going to make a call to the system catalog to go figure out, hey, what's going on? Like, is this a known type, right? Now, obviously, when you stretch this database across multiple nodes, you could have the system catalog live on a different node, and you could have your actual transaction being handled by another node. Now, if you stretch it really far apart, you could have these on completely different geographies whose latency is really high, right? And so here we are trying to run something with, the command shell or like a simple application program, what seemed to be pretty harmless, but it's taking forever to run. We're like, what the hell's going on here? Like, it shouldn't be this long. And then we realized that, this guy is actually traveling to another region to go fetch the definition of the user defined function or something, and it's going to or a stored procedure or something, and it's like, because we hadn't built caching into those layers, like we obviously have a replicated and replicated cache that we invalidate at the right times and so on, but this is something we had not cached, and we just couldn't, we were like, what is going on here? This should be like a very simple operation. It shouldn't be taking that long. But yeah, there were a number of these kind of twists and turns that we had to really go through and think about.
All right. Well, it's good to hear that they actually were thought about. There's a remarkable number of people who have claimed to solve a problem only to no longer exist 6 months later. And you clearly have done better than that. So I applaud you for that. The startup world, especially in the Valley, is rather cutthroat.
Yes. Thank you.
You're welcome. All right, so we're going to go ahead and close this out. But as I mentioned, this whole podcast is not just about data; it's about the people who wrangle it, and we want to bring a certain level of human experience that allows connectivity beyond just the technology. So, as I understand it, and being in the middle of California, it makes sense. You enjoy like surfing, for example.
I do. I enjoy most of the water sport, actually. So yeah, I do.
All right. So I grew up in Imperial Beach, California, which is basically Mexico. And I pretended on many of occasions to be a surfer. And believe me, it was pretend. I could never get up past my knees. I could never stand. But boogie boarding, I enjoy boogie boarding. But my question for you is favorite wax.
Well, you knew the answer, didn't you? It's sex wax, obviously. That's the one I use. So.
Well, actually, I didn't know the answer, but that's actually the one that I knew of. And it comes from, and we'll be dating ourselves here, best surfer movie ever.
Point Break, of course.
Point Break.
That's right.
With Keanu Reeves.
That's right. I actually watched that like a ton of times, but I didn't realize it was in the movie. I independently used that wax.
Yeah, it's actually how they end up identifying Patrick Swayze's crew, because they got the various chemical breakdown and
now I remember. That's right. That is right. Good memory.
Thank you. All right. Well, hey, it has been a pleasure having you. We hope to have you on again. Is there any final thoughts that you'd like to provide, or questions you'd like to ask?
I think
before
it's
we
been
close
great.
this down?
Thanks for having me. It was a really fun conversation.
All right. Thanks for taking the time, Karthik, and good luck to all things Yugabyte. Take care.